Hi guys, my name's Catherine and I'm one of the tutors here at Chegg. I typically tutor science, some math, English, and Spanish, and today we are going to be talking about a science topic that overlaps with bio and chemistry, which is acids and bases. So all things that are solutions, so meaning like in a liquid form, can be characterized in terms of both their acidity and their basicity. We usually only talk about one or the other, whichever one makes more sense, but all liquids have both properties. Because acidity is a measure of the ability for free hydrogens to exist, and basicity is a measure of the ability for free hydroniums, which are OHs, to exist. And the better some liquid is at allowing free hydrogens to exist, the worse it'll be at allowing those free hydroniums to exist. So the stronger an acid something is, the weaker a base it'll be, and vice versa. So let's go through a couple different examples. So first, right here, we have our water. And so water is H2O, as you know, and that can break up into one hydrogen like that, one free hydrogen ion, and one hydronium, like that. This is also called a hydroxide, by the way, hydroxide and hydronium. And so when water breaks up, it equally forms both of these, which means that water just by itself is neutral. It's equally good as an acid or a base. But interestingly, something that you won't really see happening is you're not going to see this becoming, well, let's see, I'm going to draw a really big arrow all the way over here, and then we'll erase it for clarity's sake in a minute. But you're not going to see water with another hydrogen becoming H3O plus, like that, very often at all. As soon as that happens, it'll go right back to H2O with the extra hydrogen, and that probably came from something else, maybe from a different acid, maybe from water. But that's very, very rare. If that was more common, that would suggest that that would make water a stronger base than it actually is, because doing that would take up some of the extra hydrogens, which is another way of describing a base. Rather than saying that a base allows free hydroniums to exist, you can also say that a base removes hydrogens. Let's actually add that, because there are a couple examples where one is a better descriptor than the other. Free hydroxides. Yeah, I think I said hydronium a second ago. Hydroxides. These things, okay? So this corresponds to, well, let's see. This. There we go. Okay, so we just talked about water. Now let's talk about this thing down here, HNO3. Throughout this lesson, I've made most of the acids red and the bases blue, and things that are neutral purple, because purple is between red and blue, just for clarity's sake. So we have here HNO3, and so the bond here between this hydrogen and this nitrogen is weak enough that it can pretty easily break up into an H plus and an NO3 minus. Far more likely than having an H2NO3, what would that be? H2NO3 plus. That's almost never going to happen. It's almost never going to take up an extra hydrogen. But this sort of thing is going to happen. And that extra hydrogen that's now floating around, this is what's going to make the solution that it's in acidic. And finally, we have something that's super basic over here. So we have barium hydroxide, which is made of one barium ion or element and then two OH groups. So the first thing that'll happen is it'll become BaOH plus and one OH minus. But then this part here can even react again so that we can get a second OH minus out of the solution. So that makes this a super strong base. So, so one misconception that I think a lot of people have is that acids are super dangerous and bases are safe, kind of in comparison, because the farther you are away from something that's super acidic, the safer you are, and that's wrong. So it is true that things that are super acidic are super dangerous. So we have battery acid down here. Battery acid is super dangerous. You don't want to get it on your skin. You certainly don't want to drink it. You got to be safe around it. And it's got a pH of 1. On the pH scale, the lower a number is, the more acidic something is, and the higher the number something is, the more basic it is. And it goes from 1 to 14. Put that here. Yeah. So that's super acidic, and it's super not safe. But having something that's a little bit acidic isn't necessarily dangerous. Beer, for example, has a pH of 5, so that's definitely below the midline of 7. And it's certainly a whole lot safer to get beer spilled on you than battery acid. Water, like we said before, is perfectly neutral when it's pure water, so it has a pH of 7. Human blood has a pH that's a little bit basic. It has a pH of 7.5. And then if we go all the way over here to drain cleaner, which is really, really basic, with a pH of 13.5, that's also dangerous. You don't want to drink drain cleaner by any means. There's a reason why people often wear gloves when they're working with it. So just because something is not acidic doesn't mean it's safe. So the pH scale, the H in it, is for that hydrogen ion that we were talking about here, like this buddy here, or this one. So another way to talk about acidity and basicity is through the POH instead, and that refers to this one, or, well, actually, sorry, not that one, but like this one, or this one here. And just like the pH scale, a POH scale goes up to 14. If you want to get the POH value, just do 14 minus the pH value. So the POH of battery acid is 13, the POH of blood is 6.5, and the POH of drain cleaner is 0.5. So in this case, the lower a POH is, the more basic something is. So that should do it for a basic review of acids and bases. I hope that you've enjoyed this video. If you have any further questions, I'm always available for private tutoring on Chegg.